Hello everybody! Today we're going to talk about exponential word problems for both growth and decay. So I attached a slide presentation. The slide presentation I'll follow along with that so you can have the examples there for you. I believe some of these are from the book as well. And then I'll give you some practice problems to try on your own. I'll attach that to the Google Classroom post. Alright, so on the first slide it says the equation for exponential growth. So the equation when we're doing word problems, how we're going to think about it: y equals a times the quantity 1 plus r to the t. And for this, the 1 plus r is like your b value, and you're being raised to a variable. It's like your x, but it looks a little different here. And a is going to represent your initial amount. So your initial amount. Y will represent your final amount. So that's going to be what you have in the end after t, whatever your unit of time is. So y will be your final. That says final. 1, we'll talk about what 1 is. And r is going to be like your rate of how much you're changing by, the rate that you're changing by. And r is going to be greater than 0. It's going to be a positive. This is going to be for a growth function. So that's why your r is positive, because you're going to be growing. And t is time. So if we focus on just that 1 plus r, the reason why this is a growth function, everything in here is going to be represented as a percent. So 1 as a percent is like 100% of something. And you're adding a certain percent. So maybe you're gaining 2% a day. So you have 100 and you're gaining 2 more. So this is going to be represented as a decimal, 2%. Well, this would be 1. 2% would be like, not 1, 0.02. That'd be 2%. So you'd end up with, in here, like 1.2, theoretically, if that was what the problem was calling for. It's your 100% and 2 extra. You're going to be growing. That's why it's 1 plus whatever your rate is. You have your 100%, and you're going to be increasing from there by whatever your percentage is. But we're going to represent them as decimals here. So that's all the parts of the exponential growth. So let's do our first word problem. First word problem, so it's on slide 2. I also believe it's in your textbook. It is in your textbook, page 432. The problem reads: the prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. And then our first step is to write an equation to represent the amount of the gift card in dollars after t days with no winners. So we're going to be in the form. It's a growth here because we're increasing in money every time someone doesn't call in or someone doesn't claim the prize. So y is equal to a, we're going to do our 1 plus r to the t. In the end, we're going to want to find out our total costs after t days. So we don't know those, but we do know some of the information in here. So it's going to be y equals our a, that should be our initial amount here. So initially, the gift card is worth $100. And if someone doesn't call in, the gift card increases by 2.5%. So 2.5% as a decimal should be 0.025. So we're going to go ahead and say it's 1 plus 0.025. That's 2.5% to the t power. And so like after 1 day, that would mean you have only increased by this 1 time. And we'll see how that changes after more than 1 day. But let's simplify first. 100 times 1.025 to the t. So you're going to keep multiplying by this over and over after t days. So this right here is our final equation that we can use to represent the situation. Now part B, it reads, how much will the gift card be worth if no one wins after 10 days? So you're substituting in what you know. This was our equation to represent. We want to know how much it's worth after 10 days. So you're going to take your 100, multiply it by 1.025 to the 10th power, and take your nice calculator here. And we're going to do, of course you do your exponent first, 1.25 to the 10th, and you're going to multiply that value by 100. So we get y is equal to 128 point, and we have 0084, and we go on, but we can round here. Y is equal to 128 point. For money, you should always round, not to your 10th, but to your 100th. So your gift card is worth $128.01 after 10 days. Let's talk about our decay function now. So a decay function, very similar to the growth function. It's going to be in the form, this is slide 3 on that presentation. Y equals A times the quantity 1 minus R now to the T. And very similar, this is our final amount here. A is going to be the initial amount. 1 is like having the 100%. T is time. And R is going to be the rate. And now it's a minus sign because you're decreasing. So if this is 100% and you're decreasing by 5% every day, well, that would be 1 minus 0.05. So it's going to be 0.95. That's what you're decreasing by. It's less than 1. It's going to be a decay function because you're going down. So that's why you're going to have a minus whatever the rate is. And that's every part of the equation that we'll use. We can substitute in what we know to find a missing part. So let's look at slide number 4 here. Slide number 4 is talking about a raft, and this is actually an example on page 433. So if you want to use your textbook, you can. I would use the slides, they're right there. It says a fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. Part A just says write an equation to represent the loss of air, and that's going to be after T amount of days. So we're going to be in the form. This is a decay. We're clearly losing something here. We're going down. 1 minus R to the T. We don't know the final yet. That's going to change based upon what our amount of days is. But we do know it started with 4,500 cubic inches. There's your initial amount. And it's 1 minus 6.6%. Well, this is 6.6%. We don't know how many days. That can change. Depends on how many days we're interested in. If we do a little bit of simplifying to make this nice and easier to work with, we're going to have 4,500. No back button. And we're going to have 1 minus 0.66. So you're going to end up with 0. And we should have 9 and then 3, 4 to the T power. And of course, this is a decay. We are less than 1 here. So now we just need to substitute in what we know to try and find out how much air we have after it says 7 days. So we want to find out how much air we have. So we want to find out y after 7 days. So we'll use this. Y equals 4,500 times 0.934 to the 7th power, because that's how many days have gone by. So many times we're losing our 6.6%. So we go to our calculator here. We're going to take 0.934 to the 7th power. we get our value. You multiply that by 4500. So y is going to be equal to 2,790, and it doesn't specify what to round to. Let's just round to the nearest tenth. We're not dealing with money. So you round to the nearest tenth, you have 2,790.2, and our unit here would be cubic inches, or just inches cubed. Both are good labels. This is probably better. Okay, so that would be a classic decay function. And let's say, we'll do one more. We'll do slide number 5. This is talking about Josh. So it says, Josh has 12 pennies and plans to double the amount he has every week. We want to first construct an equation to find the total amount of y of pennies after x weeks, and then how many pennies will he have after 15 weeks is going to be our goal. So this should be, if he's going to double every week, we should represent this as a1 plus r to the t. This should be a growth function. Now, if he's doubling the amount of pennies he has, you need to think of what the rate is that you're increasing by, because we're not multiplying here inside this little parentheses. So if you have, let's just say he has 4 pennies and he doubles that, he'll end up with 8. So how much did you increase from your beginning? Well, you added 4 to get there. You doubled it, but you also can think of it like you added 4, so you added 100% of what you already had. If that makes sense. You increased by, you have your 100% and 100% more, resulting in having a total of 200%. So r here should equal 1. You're increasing your original 100% by 100% more. So y equals, and our a, we should see really clearly, is 12, and it's going to end up being 2 in here. You're increasing your original 100% by 100% more, so you have 200% of the original, which is doubling. So this is your function, and that's part A. Now part B says how many will he have after 15 weeks? Well, you're going to say, started with 12, that is a 12, and he's doubling it 15 times. So you do your 2 to the 15th, and then you're going to multiply that by your 12. So you get y equals, and I calculated out to get 393,216. So Josh will have 393,216 pennies. Not too bad. Josh is doing well. Alright, that's all we have. There's some more practice problems. I'll attach them to your Google Classroom, and you can go ahead and practice a little bit. You want to make sure you're comfortable with these. Tomorrow we'll talk about a special type of growth function that we have called compound interest. Very similar to this, just a few little adjustments. It's how a lot of interest works in the world. So if you're interested in money, it'll be a fun day. Have a good day, people.